Hello and welcome to another video. On the board is another question about velocity and acceleration, and I read, a particle is moving along a straight line with constant acceleration. In an interval of t seconds, it moves d meters. In the next interval of 3t seconds, it moves 9d meters. So our task is to what? Is to find how far does the particle move in a further interval of t seconds. Now, what to do in this case is to first find the expression for initial velocity and acceleration, okay? Because it will come in the form of an expression. All right, then the expression for acceleration and initial velocity is what we need in order for us to know how far the particle will move, okay, in a further interval of t seconds. So the first thing I will do is to set up the distance equation during the first interval of t seconds. And I'll also set up the equation for the next interval of 3t seconds. Now, for the first interval of t seconds, the distance the particle moves, the particle moves a distance of d meters. Then in the next interval of 3t seconds, okay, the particle moves distance 9d meters, okay. So we're going to use one of the equations of kinematics, okay. But first, like I said, we want to look for the write the expression for. We're looking for the expression for acceleration and initial velocity. So let's say we want to find out what to be the initial velocity. So this is the initial velocity, okay, and we have a to be the what? Acceleration. So we have a as the acceleration. So now for the first interval of time, for the first interval, okay, for the first interval of t seconds, let me write it as t seconds. So we know that the distance formula, okay, will be u multiplied by the time is t seconds plus 1/2 of a t squared. So if you are using the formula, s equals to ut plus 1/2 of at squared. So where s will be equals to d, okay, and small t will be equals to higher case letter t. All right, so this will be the first equation. So the first equation is d equals to ut plus 1/2 of at squared. So this is the first equation. This is equation 1. Okay, now for the next interval of 3t seconds, the particle moves 9d meters. So which means for the next interval, of 3t seconds, okay, so we have that the distance in this case, distance will be equals to 9d, okay, distance will be equals to 9d. Then we're also going to have okay, distance equals to 9d, then t will be equals to 3 higher case letter t. So this will be 9d equals to v multiplied by 3t plus 1/2 of a multiplied by 3t squared. Now I use v. Now what does v stand for? V stands for the velocity at the start of the second interval, okay, at the start of the second interval, or we can say at the beginning of the second interval, that's v. So then v will be equals to initial velocity multiplied by initial velocity plus a multiplied by time t. So in this case, we're going to have 9d to be equals to u plus at multiplied by 3t plus 1/2 of a. Then here we have 3t squared. That will be 9t squared So we have 9t squared. So that in this case, this will be 9d. Now let me multiply this by 2. So that this will be 18d equals to, so 2 multiplied by 3t, that will be 6t. 6t multiplied by u, that will be 6ut. 6t multiplied by 80, that will be 6at, plus 2 multiplied by 1/2 of a times 9t squared. Okay, this will be 9at squared. Okay, 9at squared. 9at squared. So this will be t squared, because 2 times 3t, that will be 6t. 6t times 8t will be 6at squared. All right, so this will be 18d equals to 6ut plus 15at squared. Okay, so this is the second equation. This is equation 2. And here we have equation 1. Okay, now let me multiply equation 1 by 12. Or let me multiply equation 1 by, let me multiply equation 1 by 6. Okay, now equation 1, okay, equation 1 multiply by 6, that will be 6 times d, that will be 6d equals to 6 times ut, this will be 6ut, plus 6 multiplied by 1/2 of at squared, this will be 3at squared. Okay, so this is the third equation, so I'm going to call this equation 3. Now let me subtract equation 3 from equation 2. Okay, so this will be equation 2 minus equation 3. So 18d minus 6d, this will be 12d, okay, equals to 6ut minus 6ut, that will be 0. 15at squared minus 3at squared, that will be 12at squared. Okay, so I'm going to divide this by 12, so that this will be d equals to at squared. Remember, the first thing we are looking for is the expression for acceleration and initial velocity. So in this case, if I divide both sides again by t squared, okay, dividing both sides by t squared, this will give us a equals to d over t squared. So let me box this. So this is the expression for acceleration. So now let's also derive the expression for velocity, because like I said, we need to first find the acceleration and the velocity. So with that, we should be able to find how far the particle moves in a further interval of t seconds. So let's calculate initial velocity. Let's calculate initial velocity. So what I will do now is I'm going to substitute d over t squared into, okay, let me use equation 1 to make it faster. So into equation 1, so we have d equals to ut plus 1/2 of at squared. That's equation 1. So a is now d over t squared, then multiply by t squared. Remember, in equation 1, we have equation 1 to be d equals to ut plus 1/2 of at squared. So which means d will be equals to ut plus 1/2 of d over t squared, that is the acceleration, multiplied by t squared. So that this will reduce to d equals to ut plus d over 2. ut plus d over 2. Okay, so let me multiply this by 2, so that this will be 2d equals to 2ut plus d. So if I subtract d from both sides, okay, this will be 2d minus d equals to 2ut, so that d will be equals to D will be equals to 2ut, so that we can then u will be equals to, so we have d equals to 2ut. So if I divide both sides by 2t, this will be d over 2t equals to u. So which means the expression for u is d over 2t. So the expression for u is d over 2t. So that's u. Okay, and this is a. So we have, this is the acceleration and that is the initial velocity. So now our task, which is to find or calculate how far the particle move in a further interval of t seconds. Okay, so what I'll do first is I'll need to, the same way I did here, okay, I'm going to first find or write the expression for the velocity at the start of the third interval. Second interval, then yes, third interval. So that means I want to calculate the third interval, that's distance in the next interval. So let's represent that as d3. Okay, so this represents distance in a further interval of t. Okay, so which means v prime, I'm going to use v prime in this case. V prime will be equals to the initial velocity plus 4at, because in this case t will be equals to 4t. That's the next, that's the further interval, in a further interval of t seconds. So we're going to have 480. Yeah, so which means the distance d3 will be equals to v prime multiplied by t, because it says in the question that how far does it move in a further interval of t seconds. So the time will be t, but the velocity at the start of the third interval will be v prime, just like I use v in this case. So v prime equals to u plus 4at. Okay, now why is it 4t? Because in the next interval after interval of 3t seconds will be 4t. So in this case we have v prime of t plus 1/2 of at squared. Okay, so that this will be d3 will be, this will be u plus 4at multiplied by t, then 1/2 of at squared. Okay, so now this will be, this subscript 3 will be ut plus 4at squared plus 1/2 of at squared. Nice. All right, so we know that the expression for u is d over 2t, so that this will be d3 equals to d over 2t multiplied by t for this guy, plus 4, this will be 4.5. We have 4.5 of at squared. Okay, because this will be 2 times 4, 8. Okay, 8 at squared plus 1 at squared. That will be 9 at squared. So that will be 4.5. Okay, so t will cancel t. Then this will be d subscript 3 equals to d over 2 plus, this is 9 over 2, because 2 times 4, 8 plus 1, that will be 9. So we have 9 over 2. Then the expression for acceleration is d over t squared. Okay, then we multiply that by t squared, so that t squared divide t squared, that will be 1. So that this will be d subscript 3 will be d over 2 plus d over 2. Okay, that's d over 2 plus 9d over 2. 9d over 2. So that this will be d subscript 3 equals to 10d over 2. So that the distance, now that's That is, the distance the particle moves in a further interval of t seconds will be, because this is 10d over 2, so that will be 5d meters. So the distance moved by the particle in a further interval of t seconds will be 5d meters. And with that, we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.